All right, so if you guys notice at the top of this page, it still says G.MD.1, and that is what the last unit was titled as well, when we were just dealing with perimeter and area of all of those two-dimensional shapes. So in the past, we've talked about how to find area of a circle, a rectangle, parallelogram, trapezoid, triangle. All of those shapes were all two-dimensional because they're flat. They just lay on your piece of paper. You can see all the sides of the shape. You don't have to envision what may be happening behind the triangle or behind the circle. Okay, those are all 2D shapes. We're going to continue in this unit, but we're going to switch now to three-dimensional shapes. So this would be something a little bit more complicated than those 2D because we're not just looking at a flat figure. If you guys just look around my classroom, do you guys see three-dimensional shapes in this room? Can you give me an example of one? Anyone see something that they think would work as a 3D shape? Would this work? I don't want to touch your drink, but she's got a drink up here. What kind of shape is that? That's a cylinder, okay? Kind of like the water bottle back there on that table, cylinder-ish. It's maybe not a perfect cylinder. This would be a cylinder too, okay? My wife's up here. What were you saying, Lacey? My what?
Your cup.
My cup is also kind of like a cylinder too, yep. Okay, do we see other 3D shapes in here? What do you see, Brady?
Desk.
The desk? If it was like all filled in,
Yeah.
right? But even like the tabletop, it's kind of like that thicker edge. That's a 3D shape. Okay, it's not a cylinder anymore. That would be more of like a prism. My cabinets or any of those closets over there, those would be prisms as well. My filing cabinet back there would be a prism. Okay, so a lot of different shapes that we see day to day would be considered 3D because they have a length, a width, and they have a depth to them. So that's going to make it change from that 2D to 3D shapes. So that's what we're going to focus on today. I want to go over some of the basics of a 3D shape though, so that when you are reading through a problem, or if you hear me refer to a part of the three-dimensional shape, you know what I'm talking about. So a solid would be kind of a generic term for these three-dimensional shapes. A solid is just a 3D closed figure. So the picture that I have here on my screen, that would be an example of a 3D shape. It's got length, height, and it has a depth to it. You maybe can't see all the sides of it right now, but this would be a prism just because of its nature of kind of how it looks. It'd be similar to like my filing cabinet back there would be similar to this shape here, or even the closet over there. Or think about any type of box, any type of cardboard box you've ever seen would be similar to this shape. Now, a real fancy name for three-dimensional shapes is called a polyhedron. Okay, so this next one here, it says polyhedron. What that is it's a solid with polygon faces. Now remember, a polygon is any two-dimensional shape. So a rectangle, a triangle, a trapezoid, any of those shapes that we dealt with in the last unit, those were all going to be polygons. A circle is not technically a polygon, but it'll show up on our 3D shapes as well. So a polyhedron would be something that's made up entirely of those polygons. So you have a whole bunch of rectangles that make up the shape. Or maybe you have some rectangles and a couple triangles that make up your shape. Okay, on your polyhedron, you have something called a face. On my picture over here, this would be known as your face. That whole front side is the face. So a face is just a surface or a side of your polyhedron. Now, that's just one face. There's a lot of faces on this shape. You could also say that this side, kind of to the right, is a face. The top is a face. There's other ones too that maybe you have to envision where they would be. There'd be one in the back, there'd be one on the left, and there'd be one on the bottom here. Sometimes you'll see those drawn in, like they'll do dotted lines inside the shape to show you where those other pieces would be. But all of those would be faces of your shape. When you have two faces that meet, That's going to create an edge. So an edge is where two faces meet. They would form a line, sort of. Not a true line because it wouldn't go on forever, but like a line segment. So on my shape over here, this would be an edge. Think about my classroom right now. This is my room itself is a three-dimensional shape. Okay, all my walls could be like my faces here, and the ceiling and the floor could be faces as well. But when the two walls over here meet, when the front wall meets that wall over there, right in the middle is a line. That would be an edge. And that would happen in all the corners of my room, or anywhere where two faces kind of come and meet each other, they're going to make that edge. We also have something called a vertex. A vertex would be where your edges meet. This is going to create a point. So on my shape up here, this top corner maybe right here would be a vertex. Again, on my picture, I'm just giving you one example, but there's a lot of vertexes in this picture. There's a lot of edges in this picture. Any of these straight up and down sides, or even like this one that goes left to right up here at the top, that's an edge too. All of these corners on the top and all the corners on the bottom would be those vertexes. In my classroom again, where the walls over here and the ceiling touch, kind of up there by like the motion sensor, that's going to be a point, okay, or a vertex. Same thing happens at the floor. When the walls and the floor meet, they create a vertex as well. So your 3D shapes are all going to consist of these different things. Depending on what kind of shape you have will change maybe how many faces it has, how many vertexes it has, and edges in that. But all of these things are going to be present in these three-dimensional shapes that we're going to be focusing on in this unit. Now we're going to start out with the prism, okay? And that's what this one is. This is an example of a prism. And we kind of talked about some more prisms that we see in this room, like the top of your table, the closets over there, my filing cabinet, the Kleenex box on that back table. All of those things would be examples of prisms. What a prism is, it's a 3D solid with two parallel bases. And right underneath bases, I'm going to write another note. The bases are going to be congruent. Right underneath that, I have some examples of different types of prisms. Now, the bases for these prisms are all changing. You can kind of see on my screen, they're colored in for you. Yours aren't going to be in color, but you can kind of see they have some of those sides kind of darkened on your guys' notes. Those darkened sides or shapes are going to be known as your bases. When you're dealing with a prism, you're going to have two sides that act as your bases. They're going to be the same shape. They're going to be parallel to each other. They're going to be congruent to each other. So on this first one, what shape are they saying is the base? How would you name this shape? It's a triangle, right? So we would call this a triangular prism. That's great. So I'm going to go ahead and write that down. This is called a triangular prism. "3D solids get named by their bases." Okay? What would you guys say for the second one? What shape is your base on that second shape? A rectangle. Okay? So we would say rectangular prism. If it's a triangle, if it's a rectangle, those usually end in that ular sound. So triangular, rectangular, like those kind of attached to those names all the time. Now, when you go to the third one up here, what shape is your base? It's a hexagon because it has 6 sides. We don't put the ULAR after the hexagon. Instead, we name it a little differently. We say it's a hexagonal prism. So any of those shapes that end in the gon sound, pentagon, octagon, decagon, hexagon, all of those are going to have the AL after it. The other ones, like the triangle and rectangle, those end a little bit differently. If you have a trapezoid as your base, that would be called a trapezoidal prism. So they kind of sound a little bit different, but most of them are going to be kind of these couple of shapes where you're dealing with triangles or rectangles, or you're dealing with some type of regular polygon. Now, I just want to quickly talk about on these here, we highlighted the bases, but the other sides that aren't highlighted that kind of connect those bases, those would all be your faces of your shape. How many sides does the base shape have on this first one? Like how many sides does a triangle have? Three, okay. How many sides does a rectangle have? 4. And how many sides does a hexagon have? 6. If you look at your shape here on my triangular prism, we said the base had 3 sides. There's 3 faces. There's this one in the front. There's this one kind of off to the right side, and then there's this one on the left. That's 3 faces. How many faces does this one have? 4, because it has a rectangle, so it has to have 4 faces to connect. If this has 6 sides to it, how many faces should it have? 6. So the number of faces that your shape has is going to connect to the number of sides that your base shape has. If I was thinking about my classroom, I would maybe consider the ceiling and the floor as my bases, and all the walls would be my faces here. Okay, now I'm imagining this is a perfect rectangle. There's no like weird corners or like little divots in the corner over there by my desk. Like I'm imagining that everything is a smooth wall just connecting perfectly in here. But those would all be my faces if the ceiling and the floor are your bases to each other. Okay, but just something to take note of. The number of faces is going to directly connect to the number of sides that your base shape has. All right, now that you kind of know how to name these shapes, we're going to talk about something called a net and how we draw nets. Now, what a net is it's a 3D object flattened so that we can see every face. So kind of think about if I had that Kleenex box in the back, or if you get an Amazon box. Okay, you order something from Amazon, you get a little box that comes home. If you opened that box up and you laid it flat, like you undid all the tape on all the sides and you just laid that out so it was flat, that would be making a net. Okay, you're basically taking that 3-dimensional shape and you're breaking it down so it just lays flat. It's not making a 3D shape anymore. That's what nets are. Now, why we are using nets is because as we get going in this unit, we're going to talk about surface area and how to find the surface area of a 3-dimensional shape. We're going to be using the nets to help us do that. Okay, so I've got on the bottom of this page 3 examples where the nets are already drawn out for you. What we need to do, though, is add measurements to our nets. I need to know where these numbers from the prisms go onto my net down below. That way, in the future, I can do that step and then actually use those numbers to help me find my area. We're going to start with the rectangular prism first. Okay, just kind of take a look at the net there. The faces are all going to be in the middle. So all of these taller rectangles here, there's 4 of them, which makes sense because if it's a rectangular prism, there would be 4 sides on your base because it's a rectangle. So there should be 4 faces. These are all going to be the sides that connect your 2 bases together. These sides that they're laying off to the side, almost like little extra flaps on either end there. Those are going to be where your bases are. Now, the tricky thing about a rectangular prism is how do we decide what's the base? Because depending on how you look at it, you might identify a base differently than somebody else. Somebody might say that the top and the bottom are the bases. Think about like my classroom. I said my ceiling and my floor were my bases, okay? But someone could argue, well, I want to use the front and I want to use the back as my bases. That would work too. That'd be me saying like the front of my classroom and the back of my classroom are my bases and everything else going this way are my faces of the shape. So you can kind of argue your way through that for a rectangular prism. That one's got a little bit more flexibility when you're trying to identify things. What you need to do, though, is just kind of look at your net that they have drawn down here and figure out what makes the most sense to go where. So I'm seeing on these rectangles, these are all the longest sides out of my whole picture here. So what number do you think should go on all these sides? 17. Now, how I like to label it is I'm going to put a 17 over here, and I'm going to put a dash next to it, like this. And I'm just going to put a dash through all the other sides that I know would be 17, which would be all of these kind of going through the rectangle. Are there any others that I should put a 17 by? I don't think so. I think we got them all. So now we need to figure out where should the 7 and the 10 go. Again, use your reasoning here. You have two other lengths available to you on this picture. Some are shorter than others. 7 should probably go on the shorter of the remaining sides, and 10 should go on the longer of the remaining sides. So where would you put the 7 at? Just give me an idea. Describe to me where I should label 7. Like out of these two, which one do you think should get 7? The left one or the right one? The right one should, because it's smaller. This one should then get the 10. So I'm going to go ahead and say all those shorter edges would be 7. So this one, the one directly above and below that. And then on those flaps that kind of lay on to the sides, these would also be 7. Oh, I got to give these 2 dashes. Okay, all the other ones then should be how much? 10. When you start doing these on your own and you have to draw out your own nets, you can then decide, like, what do I want to have be my base shape? And then that will maybe change or shift your numbers around a little bit. But the overall picture of your net should really not change a whole lot depending on what kind of prism you're dealing with here, especially if it has a rectangle as a base. Now, if you look at the second one, we're switching our base shape to a triangle because it says that this is a triangular prism. So again, notice how we have our faces in the middle here. This time there should only be 3 faces because our base is a triangle. So we talked about the connection there. Triangle has 3 sides, so there should be 3 faces to it. I need to label these. Let's start with the triangle because it is a right triangle up here because there's that little box in the corner. What do you guys want to label on the triangle? Where do you want the 4 to go? Okay, someone want to help him out? Where should the 4 on this triangle go? Brady?
Bottom side.
The bottom side? Because if I look at my triangle, the sides of the triangle are 3, a 4 from up here, and the 5. 5 can't go down here. 5 has to be the longest side, so that's got to go across from the 90-degree angle on this one. So I know my hypotenuse has got to be that 5, which means that the longer leg needs to be 4 because the shorter leg is 3. Okay, so the 4, let's go ahead and start with that, is going to go here and here. The 5 we talked about is the longest side of your triangle, so it's got to go all across from the 90-degree angle. And the 3 is that shorter leg. Okay, what other measurements on my faces should I put the 3 on and the 5 on? The 4 is already connecting to this face here, but how long should these ones be labeled as?
The left side should be 3 and the right side should be 5.
Good, the left side should be 3 and the right side should be 5. You have to sometimes almost think about if you folded this back up, how they're going to overlay on top of each other to figure out where some of those numbers are going to go. All right, that takes care of the majority of it, but how much does the rest of this get? 10. Because that's how tall the prism is. That's how far apart those triangle faces are from each other, those bases that we had. So that whole side, the rest of the rectangle is going to be 10 all the way across. Good. All right, why don't you guys take a minute and try to do C on your own? All right, so this last one is a hexagonal prism. Now it's a regular hexagon. When we're dealing with prisms in this unit, we're not going to be giving you an irregular polygon as a shape when you're dealing with something that's like a pentagon, hexagon, and that. So this means all these sides on this hexagon are going to be the same. How long is a side on the hexagon? 5. So 5 is going to take up a lot of room on your picture here. 5 should have gone on all of the sides of the hexagon. And it's going to go on a lot of the sides of your rectangle. Because you're thinking about this box kind of. All of these rectangles hit an edge of that hexagon, so they should all have 5s. Okay? How tall are these rectangles? 7. There's one more measurement we should maybe still include in our picture of our net. What is that? The 4.3. What do we call this on a polygon? It's that funny word from the last unit. Anyone remember it? Starts with an A. The apothem. Okay, we probably want to include that in there as well, just because in the future we'll actually start finding surface area, and we'll have to maybe think back to how do we find surface area of a regular polygon? We took the apothem times the perimeter divided by 2. So it's nice to have that drawn in our net so that when we're looking at those shapes, we can figure out how much the area would be. All right, are we feeling okay about labeling nets like that? Don't overcomplicate it, okay? Sometimes I feel like when you do it for the first time, it feels maybe a little bit like there's a lot going on. There's a lot of numbers, there's a lot of shapes. We're not done. Turn your guys' page over. Because what we're going to do now is draw your nets, okay? So they're not going to give one to you. You're going to need to sketch it out. Now, you had examples on the previous page to kind of help you with this. So we're going to do these here. We've got a rectangular prism for A. What would you guys call shapes for B? Triangular prism. What would you guys call C? That's a cube. How do you know it's a cube?
Because it's not like long like a prism.
Yeah, it's not super long like a prism. All the sides are the same length, it looks like there. And then D, how would you guys name that? Good, hexagonal prism. Okay, so when you're drawing out a net by yourself, I would think about what's your base so that you know how many faces should I have, how many rectangles in the middle should I be drawing, because that's going to be the same number of sides as the edges on your base shape. And then attach those bases on either side of those faces that you draw out. Okay, so for example, on my prism up here, I know that I should have 6 total rectangles. when I'm working with my bases are a rectangle here, so there should be 4 faces that connect the 2 base shapes. So I like to draw out kind of a longer rectangle in the middle here, and I'm going to split that into 4. And then you need to add on the bases. There needs to be one that comes up here to the top and one off the bottom here. When you're drawing your nets, I'm not going to be super picky about you drawing it perfectly to scale, that everything looks like, yes, this one does look like it's bigger or smaller than this one. Okay, you just need to get the overall shape and be able to label it appropriately. Again, depending on what you think is your base, that can change where you start to label things. If I use the 19 and the 15 as my base, those are going to need to go on those shapes that I put on like the top and the bottom. So I would maybe say that this side is 15. And I'd say maybe this side is the 19. Okay, and then I'm just labeling it kind of like what we did on that previous page. We did one like this, so we kind of should see that some of those markings are still going to line up together. And then all the way across should be that 12. So it's really no different than what you're doing on the page before. It's just you actually have to draw out the net this time. So I'd like you guys to take the next couple of minutes here and try to do the remaining 3. Draw out your net. If you need to, look back at the previous examples that we just did because there's nets that we saw. That would help you. And then try to label it all on your own. I'm going to give you guys like 2 to 3 minutes here to do that. And then I'll make sure that they get filled out up here too so you can see if we got the same thing. Okay, I'm going to start labeling these. I've got mine drawn out. For this first one, you're dealing with a triangular prism again. Again, it's a right triangle, very similar to the one that we saw on the previous page. The only thing that they really changed is just the height of the prism for this one. So these are 3, the shorter legs. These ones are going to be 4, the longer legs of the right triangle. And then the hypotenuse should have been the 5. And that should also go to the right side of that rectangle. And then all the way across should be a 7. Okay, so that's how I would have drawn that one. Like I said, really similar to that one on the previous page. They just changed the 7, that height. Okay, then we talked about C being a cube, which means it's basically got squares for its side. So how much does every single measurement get on this picture? 13. They're all 13. So it should have just been a lot of dashes or a lot of 13s if you're writing out all the numbers. Okay, but that'd be like a dice is a perfect cube. So that would be an example of something like that. Okay, and then this last one is this regular hexagon. Again, it should have 6 rectangular faces all the way across. These would all be 12. The length of a side of the hexagon is 11. And that, again, takes up all the sides of the hexagon, but it also is going to take up the remaining dimensions on the rectangle. And then make sure on that last one that you also had your apothem labeled. That should just be that 9.5. All right, any questions on drawing out those nets?